All right, now we're going to dive into a specific type of function, and basically all of those generic graphs that we were talking about, you can kind of put those together to get our piecewise functions. So what we're really going to talk about right now are piecewise functions, and notice how the word piece is spelled, P-I-E-C-E. So we're taking a part of one function and a part of another and putting them together. That's what makes a piecewise function. Now also, this is still a function, so that still means that the x's can't repeat. As soon as you know about something being in a function, everything about a function still works. So if the x's can't repeat, you know it has to pass the vertical line test. So we're talking about functions, so all of those things happen. But the key here to this one is it is a piece of a bunch of different functions put together. So P-I-E-C-E, we're not turning ourselves into a bunch of hippies here, like peace and love, but a piece, which is just a part of a function. Cool, let's check this out. Okay, here's an example of what a piecewise function looks like. Notice we have the function notation here of f of x, and then this is supposed to be a squiggly bracket, but they're hard to draw, so that's a squiggly bracket, and then I take the top piece, which is linear, and that top piece only occurs if x is less than or equal to 2. Then you take your bottom piece, and that linear function only occurs if x is greater than 2. So here's my next question for you. I got a 2 over here on the right-hand side. If I'm looking at this 2 over here, both of these 2's on the right-hand side, then how do I know that it is a function? Looks to me like I've got 2's. What about that tells me it's not a function? Right on. This one on top is or equal to 2, and the bottom one is just up to 2, but not including. Good. So the fact that the top one has an or equal to sign and the bottom one does not, that is what makes it legit. So 2 only counts for the top piece and not for the bottom. Sweet. Let's do this. I want to find some values of this function. I technically want to find f of negative 4. Now when you look at this f of negative 4, all I really want to know with that notation, let me say this, with that notation, this negative 4 is actually an x value, right? So to determine which piece I plug negative 4 in, because remember the x's can't repeat, so it cannot go into both. It can only go into one. So whenever I'm looking at this, my negative 4 has to fit the criteria over here on the right. So what would that be? The top one, right on, because x is less than or equal to 2, and negative 4 is certainly less than 2. So I'm going to use this top piece in order to plug my negative 4, and then we can figure out that value. Awesome. Then you just do work. Negative 2 times negative 4 is 8, and then 8 plus 5. F of negative 4 is now equal to 13. Now remember, with function notation is super awesome in multiple ways. The first way is the fact that, okay, f of negative 4 equals 13. How else could you write that? If you wanted to get fancy pants and you write it as a coordinate point, how would you write that? Right, negative 4, 13. Good. X is the negative 4, and y is the 13. Cool. Let's do one more. What if we wanted to find f of 2? Are we plugging that one into the bottom one or the top one? Yeah, into the top one again, because it's or equal to 2. So if I want to find f of 2, remember your x's can't repeat, so it can only go into one of them. And because it's or equal to 2, that's what makes it the top. Good. So negative 2 times 2 is negative 4 plus 5 gives me f of 2 equals 1. And again, you can write that as a coordinate point. I'm really just looking for it in in function notation right now. Good job. Let's throw one more in here. We got a little bit more room. What about something like this, f of 8? Top or bottom? Yep, the bottom one. And remember, the only thing you're looking for when it comes to this 8 to determine where you plug it in is what the x values are that are associated with it. So I have 8 plus 1. So f of 8 in this instance is actually equal to 9. That's a parenthesis. Good. Awesome. Okay, let's take that same function that we plugged values into and graph it. Whoop, whoop. You know we love some graphing. So if we want to graph this function, remember I'm graphing two separate pieces. So what I like to put into my graph is a cheater line. My cheater line is going to happen at 2 because that's where I know the split of my pieces are. Because it's defined where x is less than or equal to 2 and greater than 2, that is where my graph is split up. So I'm going to put a cheater line in there. And I'm just going to put a dashed line in there for now. And the cheater line isn't necessarily part of my graph. It's literally that. It's just going to help me cheat a little bit. So I know the left side of my graph is going to be what? Yeah. Y is equal to a negative 2x plus 5 because that is where my x values are less than or equal to 2. Now then, with that in mind, what's going to be on the right side of my cheater line? Yep, exactly. Y is equal to x plus 1. So on the right side of my cheater line, I'm just looking at these values. So where the x values are greater than 2, that's what's happening to the right of the cheater line. Where the x values are less than or equal to 2, that's what's happening to the left. Now, there are several ways to graph this thing. Here's my personal suggestion. Whenever you go through here, I like to break it up into two separate pieces. So I want to know, well, where's my graph starting? I want to find f of 2 of my first function. Because I want to know where my graph starts. Because what are these graphs really? Yeah, they're lines. You're exactly right. And in order to graph a line, you have to have two components, right? A slope and a point. Well, I want to figure out my starting point. Where does this graph start in relationship to my cheater line? And that's what we're going to find. So f of 2, just like we found out previously, is 1. Which, remember, that's the same thing as my coordinate point of 2, 1. Now, the big question here is, if this is the point that's on my cheater line, is this one going to be solid or open? And how do you know it's going to be solid? What about this tells you that it's going to be solid? Yes, you guys are so smart. If I'm looking at this, because this is an or equal to symbol, you know this is going to be a filled in dot. Because x is less than or equal when you have this top function. Good. So it is going to be a filled in dot here at the point 2, 1. Okay, so I've got that nice filled in dot. And now I have a point of 2, 1, and I have a slope of negative 2 over 1. And I can just get my slope literally from y equals mx plus b. So from that point, I'm going to go down 2 over 1. Now, here's my question for you. Typically, I'm going to go down 2 and over 1, and that's going to give me this point right here. If I'm graphing that top function, am I allowed to have that purple point? No. Good job. Why not? Yep, it's on the wrong side of the cheater line. Okay, so if we can't have that purple dot there, let me erase it and get it off of there, then we want to keep graphing the other direction. Well, if you have a negative slope, how can you go the other direction? Yeah, up 2, back 1. Make a point. Up 2, back 1. Make a point. Oopsie daisy, come on, point. Up 2, back 1. Up 2, back 1. Good. You can make as many points as your little heart desires. So we know the left side of the cheater line is going to look like that. Awesome. Let's take a look at the right side of the cheater line and see if we can pull something off there. So I want to know again where my graph starts. So I'm going to plug in where f of 2, it goes into my 2 plus 1. So f of 2 is going to equal 3. Now here's the question. Is this going to be a dashed or solid point? I'm sorry, not a dashed, but a whole or a solid point. Yes, the x's can't repeat, so this is actually going to be an open circle. It's going to be a hole there at the point 2, 3. Good. So at my point 2, 3 up here on my cheater line, I'm going to have a nice big circle. It's a hole at that point. And then I look at my slope, and again, you get your slope from your mx plus b. So my slope is 1. So I'm going to go up 1 and over 1 and make another point. So I have a nice open circle there as a whole, and my graph is going up. So the two pieces of my function here are the blue and the green, and that makes one graph. And remember I said your cheater line isn't actually part of your graph, so I'm going to go ahead and get rid of it right now. Erase out that cheater line, and that is your actual graph. Now on your paper it's going to be monochromatic, but I wanted to put 2 different colors on here just so that you could see the 2 different pieces and we could really make that distinction. Otherwise, you typically just use one color. Good, let's try to graph one more.